Alright, so here's a weird curiosity. There's a thing called an integrating factor. And I'm not going to expect you guys to spontaneously supply integrating factors as a technique. So don't go to this on exams unless I tell you to. This is a rabbit hole that goes a long ways down. But there is such a technique, and it's kind of cool, so I'm going to spend a second on it. But when I ask you an integrating factor question on the test, it's going to say, here's something that is an integrating factor for this equation, use it. Or find an integrating factor for this equation. It's not going to say solve differential equation with no further in, right? It's going to have the word integrating factor in it. Cool? So the idea of an integrating factor is you have some equation that's not exact. So you have something like m of x and y dx plus n of x and y dy is 0. And we're going to suppose that this equation isn't exact. What would that mean?
It failed the partial thing.
Yeah, failed the partial thing. So the partial thing would be you take the partial of m with respect to y, and wonder if that's equal to the partial of n with respect to the other one, x. And isn't exact means that that failed. You guys good with that? So this thing is not working, right? There is this thing where you're like, but what if it was? Like, what if I could force it, right? In the same way that you're like, okay, the homogeneous solution doesn't solve this, let me multiply it by something and maybe that'll fix it. Right? This is that exact same thing, but for exactness instead of, homogeneous solutions. So, you're like, alright, let me supply an example. So, here's an example of what I mean. So, say we had the equation 3x plus 2y squared dx plus 2xy dy is 0. So let me check first that this isn't exact. So, take some partials. Partial of this with respect to y. Wrong symbol.
4y, 2y.
Gives you 4y. This guy's partial with respect to y gives you 2x. And you're like,
Wait.
You take it with respect to x.
thank you.
It's
So you get 2y, and you're still like, damn it. Okay, so right now this is standing at not exact. Oops. What would you try at this point?
Multiply 2.
Separation.
Just add
for-
a 2.
Oh, sep doesn't work for me.
You have to add, you have to multiply to the whole thing, obviously.
Yeah, you'd have to put it on the whole thing, right? So you'd be
Just leave
like,
it on the outside of one of them and take care of it later.
no. You can't multiply bits and pieces of equations by numbers.
Just throw
That would make life a lot easier, though. Let me tell you how, if that worked, I would solve all differential equations. I would multiply one of the parts by 0.
We could just
Whichever part was least convenient.
throw another equal sign, throw a third of the thing on the other thing, and then put squiggly lines in front of all of them.
No. So, one thing you might try is like, okay, so it fails to be exact. I'm going to go to one of my other options, right? So I might rearrange and try for separable, or rearrange and try for linear or something, right? Like you have other techniques. See if you can force it into one of those. This will be inconvenient for those.
Bernoulli's, is that called?
This guy?
Yeah. You don't have y squared?
You're gonna have a dy, you're gonna have a dy, right? A y prime here, times a y.
Oh, okay.
You could maybe divide by y, maybe it'd work out. It's probably a disaster. Let me just try multiplying by x, just for kicks. Right? I'm gonna multiply an x through the whole thing. Because basically I've given up hope on other techniques, so what the hell. So if I multiply an x through here, I got 3x squared plus 2y squared x plus 2x squared y dy. Oops, I missed a dx. Is 0. So you're like, alright, cool, I did that. Now what am I looking for?
Partials.
The answer.
Yeah, just for dumbness, I'm going to check exactness again, right? So, okay. So let me check exactness now. So I should take the partial with respect to y of this first thing. And what do you get?
No.
Y.
You get 4y, but now there's also an x. So you get 4yx. Okay. On this guy, you need to take the partial with respect to x. Oh, no shit.
Bada bing, bada boom.
Cool. Now it's exact, right? You guys see that?
Yeah.
So now I can solve this. That's super weird, right? Because this equation and that one don't really seem to be the same. But all I did was multiply both sides by an x. They're going to have the same solution. That's totally nuts.
So do we just guess what to slap on there?
Is that legal?
Yeah. So, yes, it's legal. It does introduce a problem into your domain, right? The guy just multiplied both sides of this equation by x. What if x is 0?
Oh.
Right? If you have an initial condition that's like y of 0 equals something, that ain't helping, right? But if you have y of 1 is 17, you're getting somewhere. You guys cool with that? So, there are some caveats to this technique, but as far as reasonableness, like, yeah, I've been multiplying both sides of equations by things for a long time. It seems legit. Slight weirdness, but it's okay, right? So the place that you do this is when you're solving equations, right? You multiply both sides by x. Anytime there's an x on the bottom, right? You want to get rid of it. So this is kind of the spirit of an integrating factor. It's also why integrating factors are stupid hard to find.
Integrating factor is just what you multiply by, correct?
Yeah, so the x here was the integrating factor. And that could be a function of x and y.
Ooh.
Is
So
there a method to
XY?
find them?
I'm going to show you a method to find them in the simplest possible case that doesn't always work. But
You sound miserable.
the really cool thing is that one of the techniques you can always try is to just throw integrating factors at it.
Just any.
It's like on the old exams when you're younger, like you plug everything in and try to see what works.
Yeah, this is like literally the guess and check of differential equations. It's like, shit, I don't know. My techniques are all broke. Like, it ain't working. You can spend an hour and throw integrating factors at it, and maybe you'll get somewhere. Yes, this is a good thing for a computer to do.
Can there be more than one for any given problem?
I have absolutely no idea. That's a really good question. My gut reaction is probably, but I have no good mathematical reason to back that up.
So you would plug these functions into a computer, and you'd be like, hey, just keep plugging in X, Y, or any sort of thing.
Yeah, you just do, like, while you haven't solved it, try an integrating factor, check if it's exact. If it's exact, solve it. If it's not exact, go back to the beginning and try a different integrating
So
factor.
X to the N and Y to the R, just keep plugging them in.
Sure, Yeah, or sums thereof, or exponent, like x to the y's, or whatever. Like, there's all sorts of mess you can do with
That's how
this.
you overload the computer, just.
Yeah, I mean, it just burns processing power, but that's fine.
So, is there like a list of most common integrating factors, or is it just completely random based on the function?
That's a good question too. That's kind of a weird question, because if you pull a differential equation out of a barrel, I don't know what that means.
It was made by someone, and
Like-
people are really bad at being random.
Yeah, so I'm gonna show you one that works for kind of polynomial type things, pretty commonly. That said, yeah, there's not a rhyme or a reason to it that I know. My guess is that the categories have to match roughly. Like, you're probably not gonna find that if you have a polynomial and a polynomial, probably sine of x is not gonna be an integrating factor, but there's nothing to say it can't be, I guess. Yeah. That's an interesting question philosophically. Let's see. Okay, so it can add some things that are a problem. For instance, if you took this equation, and this isn't an integrating factor for this one, but if you multiplied this equation by x minus y squared, like the whole thing, and then found that it was exact, you would have some issues with like, this is 0 anytime x equals y squared, right? So all along that whole kind of sideways parabola, I would have just introduced a solution that didn't exist before. For instance, 0 is often an integrating factor.
You
No.
can do that. But like that's
Right, if you multiply by 0,
0 equals 0, it's
like,
fine.
yeah, you get something that's exact, but it's not helpful, right? So anytime this thing's actually equal to 0, you're gonna have some weirdness go on. So that's not such a big deal when you're multiplying just by x, right, or just by y. Then you just have to avoid a vertical or horizontal line. But when you're multiplying by something like this, then you have a whole set of solutions you've just thrown in.